Alright, so good afternoon everyone. Okay, so for today we will continue with the special discrete random variables. Okay, so previous or last week we cover for the discrete random variables. Okay, but then for today we will cover for the special discrete random variables. So we will see there will be another three. Okay, for this module we will introduce with the three of the special discrete random variable. The first one is a binomial. Okay, the second one is the hypergeometrics, and the third one is a Poisson. Okay, so binomial, the second one is the hypergeometry, and the third one is a Poisson. Okay, so each of the distribution for today, they have their own properties, they have their own characteristic. Okay, so they have also their own parameters. Okay, all right, so because of this random experiment, okay, we involve in the real life application. Okay, so there will be another three special discrete, okay, will be introduced for today. Okay, so we proceed with the first. Okay, we proceed with the first distribution, is we call it as a binomial distribution. Okay, so from the previous one, okay, we study the normal distribution. Okay, normal distribution, whereby the normal distribution we have the parameter itself, right? So we have mean, we have the variance, and also we have the standard deviation. Okay, but then for the binomial, they have its own parameters. Okay, we'll see this one from the model. Okay, so the definition of the binomial is okay, so we're waiting for this projector to show the second slide. Okay, so this slide you can get from the my times, okay, under the lecture. Okay, special discrete random. Alright, so the definition is the number of acts of success in the Bernoulli, okay, in a Bernoulli trial is called as a binomial random variables. Okay, the probability of this random variable is called the binomial distribution. Okay, and then we can see from the definition, we look at the probability distribution, or this one we call it as a PMS. PMF, okay, probability mass function. Okay, so for the binomial, okay, this one is a number of success. Okay, so you should have the number of success, right? So definition 2.2 is a random variable x has a binomial distribution, and its probability distribution is given by, okay, so this is the PMF. Fx is equal to, okay, okay, so this one is a, since this one is related with the discrete, okay, so you can see that the value of n is 0, 1, 2, 3, 4 until n trial. Okay, we have few trial in this binomial, okay, and then the number will be in a discrete. Okay, so this one is the number of trial. Okay, so we can conclude, or we can write our binomial distribution by this. N is a binomial distribution with the parameters n, and then we have p. What is n? What is p? N is the number of trial. Okay, x is a distributed binomially with the n. This is parameter. Okay, this is a number of trials. Okay, and then the p is a probability of success. Okay, so there are two parameters for this one. Okay, the first one is the number of trials. Okay, and then the second one is p. P is equal to probability of success. Okay, so you can check the parameters based on the definition. Okay, because we have in the definition 2.1 is the number of acts of success in Bernoulli trials. Okay, so it must be based on these two parameters. Okay, so the first one is the probability. Okay, so n x. N is the number of trial. Okay, this one x is referring to this, which trial. Okay, and then what is a theta here? Theta here is also same as a p, which is probability of success. Okay, in some of the reference book they might use this one or they might use this one. Okay, but basically they will use P. Okay, right? So Fx is equal to Nx P right? You can write like this, okay? So this one is a number of trial and then P is the probability of success. Okay? Alright, and then Q is a probability of fail. Probability of failure. Okay? So P plus Q is equal to 1. Okay, P plus Q is equal to 1. Why? Because the probability of success plus with the probability of failure is equal to 1. Okay, the total probability you studied before is always 1. Okay, alright. And then N is number of trial. X is a which trial. Okay, and then for X is equal to 0, 1 until N. Okay, alright. So how to transform this one? Because this one is a mathematical concept. Okay, so NX. How to transform this one when you want to calculate this formula? We can transform by using the combination. Okay, so Fx is equal to NCX. Okay, you transform them by using the combination formula. Okay, we can transform them into the combination. Okay, so P normally they will give to you. Okay, so two basic things for the Bernoulli is a P and also N, the number of trial and also the probability of success. Okay, alright, so Q, you can get the value of Q based on this value. P plus Q is always equal to 1. Okay, so the X is depend on the question. Okay, sometimes they started with 1 until N. Okay, right. So this is for the Bernoulli. Okay, it's a part of the discrete. Okay, how you know that one is a part of discrete? Based on this. Okay, based on the 0, 1 until N. Okay, alright, so we took as an example, okay, one specialist medical doctor, okay, claimed that 70% of those with the diabetes are from the fast food consumption. Okay, if his claim is correct, okay, so the question number 1, find the probability that 10 such patients recently admitted to hospital, 5 consume the fast food. Okay, so one specialist claimed that 70% of those patients is from the patient who consume the fast food, right? Okay, so what is 70% there? Why is the 70% there? Because this is a binomial question. It is always, we need to find the X is a binomial with the number of trial and also probability of success. Okay, so 70 is claimed as a probability of success. Okay, but then you need to transform them into the 0.7. Okay, so the N is equal to, okay, question number A, find the probability, okay, find the probability of 10 such patient, okay, recently admitted to the hospital, 5 consume the fast food. Okay, 5 are consume the fast food. Okay, example 1, question number A, the first one that we need to identify is number of trial and also the probability of success. Okay, so from the question A, the number of trial is equal to 10. We have 10 patients. Okay, so that is why we call it as a discrete, because we have 10 patients. Okay, we cannot have 10.21 patients and so on. That is a considered as a discrete. Okay, so number of trial is equal to 10 and probability of success is equal to 70%. Okay, so it is equal to 0.7. Okay, Alright, so if you can complete these two information, then you can answer this one. Okay, for the question A is find the probability. If you want to find the probability, means that the number is always less than 1. Okay, alright, so patient recently admitted to the hospital, exactly 5. Okay, exactly 5 means that this one will be probability of x is equal to 5. Okay, so we write the general formula first. NCS. So exactly 5 will be so what is the probability? Your answer must be within 0 and 1. Cannot be more than 1 because the question is a probability. What is the answer? This one, what is the value? 10C5? 10C5. What is the value? 0 and multiply by this one. 0.7 to the power of 5. What is 0.7 to the power of 5, class? 0. This one, 0.3 to the power of 5. Zero point zero zero 0.00243. Okay, so altogether what is the value? Because the probability, the value will be within this range. What's the value, Adi? 0.2919 like this. Okay, acceptable. The result and the value is acceptable because the value of probability should be between 0 and 1. Okay, it must be less than 1. So the probability when 5, okay, patient is equal to 0.10 to 9. Okay, so we stay with the question A. Okay, we stay with the question A, but we change the sentence there. Okay, that one is 5, so we change to at least 4. Okay, still with the question A, but then at least 4. Sorry, at least 6. Okay, at least 6. Okay, so at least 6 patients consume the fast food. Okay, at least 6 mean that this one, at least so 6 will be included in our calculation. Okay, at least 6 mean that this one, probability of x is equal to 6 plus probability of x is equal to 7 plus probability of x is equal to 8 plus probability of x is equal to 9 plus probability of x is equal to 10. Okay, right? So you see that one is a discrete one. 6, 7, 8, 9, 10. The number cannot be broken down into the continuous one. Okay, so probability of at least x is greater than 6. No, this one we still with the question A, but then we change to the at least 6. Additional example. Okay, so at least 6 will be like this. Okay, probability of x equal to 6, 7, 8, 9, 10. Okay, so you need to compute all the formula. Okay, so which means that n 10 C 6 0.76 0.4 4. Okay, plus with the 10 C7 0.77 0.33. Okay, plus with the 10 C8 0.7 8 plus 0.32 plus 10 C9 0.79 0.3 1 plus 10 C10 0.710 0.30 0.3 to the power of 0 equal to 1. Any number with the power 0 equal to 1. Okay, then simply you put 0 there. Okay. Any question, class, for this binomial? So basically, you need to understand this one first. Okay, this formula. Okay, basically you need to understand the formula or the Fs probability mass function. Okay, understand this formula first, and then from this formula we need two parameters, which is the number of trial and also the probability of success. Okay, there you can derive all the formula. Basically they are repeating the same formula. Okay, but then change in terms of numbers. Okay, alright, so we proceed with the question B. Alright, so question B is also find the probability. Okay, so the value of probability must be equal or within the 0 until 1 only. Cannot be more than that. Okay, right, so this is the theory. Okay. Alright, so we proceed with the example 1, but then okay, example 1, question B. Okay, question B is find the probability, the same answer, the same question, okay, that 20 are recently admitted to hospital, and then more than 6. Okay, more than 6 is from the fast food consumption. Okay, so this one we already changed our number of trial. Okay, so X is a binomially distributed with the number of trial, which is 20, and then probability of success is a 0.7. Okay, alright. So in this one, more than 6. So 6 are not included. Okay, if at least or at most means that the 6 is included. Okay, but more than or less than, fewer than, we are not included the 6. Okay, so there will be a probability of X is greater than 6. Okay, probability of X is greater than 6. Okay, which means that probability of X is equal to 7 plus probability of X is equal to 8 plus probability of X is equal to 9 plus until the last one, probability of X 20. Okay, very long calculation for this one. Okay, alright, because it started with the more than. Okay, so more than the way you change the information is more than will be like this. Okay, at least 6 will be probability of x is equal to 6. At least 6, okay. At most 6 is equal to probability of x 6. Okay, if you see this sign, and this sign means that the 6 is included. But if you see this sign, then 6 is not included. Okay, alright, so which means that probability of less than 6. So 6 is not included in our calculation. Okay, so since this one is probability of more than 6 will be 7, 8, 9, 10, 11, and so on. Okay, but since the total probability is equal to 1, so we can minus. Okay, probability of x is equal to 6 is equal to 1 minus with the probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 3 plus probability of x is equal to 4 plus probability of x is equal to 5 plus probability of x is equal to 6. Okay, still long calculation also. Okay, alright. Okay, since this one n, okay, since the calculation, the longer the number will affect the calculation. Okay, so maybe we limit the n is equal to 8 maybe. Alright, because you still computing the same thing, but then you need to change the value only. Okay, so just to show this one. Okay, alright, so after you get all this one, then you put the value 20 c 0 0.7 to the power of 0, 0.3 to the power of 20 plus with the 20 c1 0.71 0.3 19 and so on. Okay, alright, but then since this question is find the probability, the value must be within more than 0 but then less than 1, because this one is for the probability. Okay, same like the question A, even though the number of n is increasing. Okay, alright, so this one is a binomial. Okay, so we proceed with the mean. Okay, same like the discrete. Okay, same like the normal discrete. Okay, we also have the mean and also the variance. Alright, so the mean is equal to mu, and then mean is equal to n theta. So it is equal to number of trial multiplied by probability of success. Okay, and the variance is equal to, variance is also equal to npq, because 1 minus theta is equal to q. So number of trial multiplied by probability of success multiplied by probability of failure. Okay, so you get the variance for the binomial distribution. Okay, so how to recognize that the question is a binomial distribution? Adi, how to recognize that question is a binomial distribution? Yes or no? Normally they will mention the probability of success. The keyword is this, like this. Okay, from the previous discrete we don't have that 70%. Okay, this one we have the probability of success. Okay, later we will do the tutorial and then we'll let you know how to identify that question is related to the binomial. Okay. Alright, so we go with the second distribution for the discrete. Okay, this one is a hypergeometric. Okay, hypergeometric. Okay, so the Alright, so this one is for the hypergeometrics, okay? So for the formula for the hypergeometry is based on the two types of object, okay? Either you female or males, defective or non-defective, success or failure, okay? So the population is based on two conditions, okay? Either the female based on the gender, the second one is failure or pass, okay? And then defective or non-defective, okay? Alright, so such that there are A item of one kind and the B item of another kind. So A plus B equal to the total population. Okay, maybe we can consider the gender will be A for the male and then for the female is a B. So A plus B will lead to the total population. Okay, so the probability of selecting without replacement. Okay, probability of selecting without replacement a sample size N with X item of type A and N minus X of the type B. Okay, so very complicated definition, right? Okay, so is probability of X is equal to A C X, alright, the same like binomial, multiplied by B C N minus X. Okay, and the rest we need to A plus B is the total population, and then C, and then this one is a number of trial or sample. Okay. So the characteristic of this hypergeometry is based on the binary population, okay? Binary type of population. Okay, only two conditions. That is why A and B only. Okay, so look at the example. Okay, how to recognize this one? Okay, 10 people apply for a job as an assistant manager of a restaurant, okay? 5 have completed the college and 5 have not. Okay, so we see that there are two populations. Among 10 application, okay, 5 we have completed the college, which means that graduated, okay, and then 5 not, okay? Alright, so if the manager select 3 applicants at random, find the probability that all 3 are college graduate. Okay, so the first population what is the first population, class? Is a graduate. Okay, second non-graduate. Okay, alright, so what is the value of N? What is N there? What is N? No, I mean, what is the definition of N? N equal to 3. X also equal to 3. Okay. N is equal to number of sample selected. Okay, so the manager only select 3 applicants. Okay, alright, so out of all is 10. Right, so 10 is from the 5 here, 5 here. So you got 10. Okay, alright, so the first is a college student, the B is a non-graduate. Okay, so the number of applicants selected by a manager is only 3. Of 10, we select only 3, and then find the probability of 3 college graduate. Okay, probability of X is equal to 3. Okay, so the hypergeometry, you can easily recognize the population, easily recognize the question, because this one is only involved with the 2 population question. Okay, so that one will be the A. A is 5. Okay, 5 only select 3. Okay, 5 only select 3. Multiply, okay? Multiply with the B. 5 also, C0. Why C0? Because they don't want to select any non-graduate. Okay? Divided by A plus B. Graduate and non-graduate is a 5 plus 5. And then C is equal to 3. Okay? We have 5 graduate and then we have 5 non-graduate. Okay? So the X only probability that all colleagues are graduate. Okay? Probability of X equal to 3. Okay? Right. So since this one is 5, C3. They want only select 3 sample. So 3 plus 0. Okay? This one and this one. Alright? So basically 5 here, they will lead to here. Same. 3, 0 will be here. Okay? And then this will be the formula. Okay? Any question for this one, class? Okay? Easy, right? Okay, alright. So we see the tutorial question. Okay, during the tutorial session. Alright, so we have this one. A recent study found that 2 out of, sorry. Okay, a recent study found that 2 out of every 10 houses, okay, in a neighborhood have no insurance. Okay, so if 5 houses are selected from 10 houses, find the probability that exactly 1 will be uninsured. Okay, so 1 houses will not taking the insurance. Okay. Alright, so for this one, how to identify the question? Okay, the first one is based on the 2 population. The A is equal to have no insurance, right? A is equal to not taking any insurance. Okay. Okay, A is equal to not taking the insurance, and then B will be, did they mention the B? Did they mention the B? What is the value of B? So 10 minus 2, because A plus B equal to total population. Okay, so A plus B is equal to 10, so B is equal to 10 minus 2. Okay, so it is equal to 8. Have or take the insurance. Okay, right? So if 5 houses are selected from the 10 houses, okay, find the probability that exactly 1 will be, uninsured. Okay, that one is not taking the insurance, right? Okay, so for this one, probability of X is equal to 1, right? Exactly 1. So there will be 2C1 multiplied by 8C1 also. Okay? Sorry, because 5, sorry. 5 are selected, right? Okay? So 2 plus 8C5. Why 5? Because they select 5. Okay? But then exactly 1. So probability of exactly 1. Exactly 1, no insurance. Okay? So out of 2, there will be 2C1 multiplied by 8C5. C4. C4. Okay? So because 2 plus 8 will be here, 1 and 4 will be here. Okay? Right. So can you find the value for the 2C1? What is the value for 2C1? What is the value of 2C1? 2, right? Okay, 2. So 1C2 Can you find the value of 1C2? 1C2. Huh? 1C2, you get the value or not? Hmm. 1C2, you get the value? No value. Have value or no? No value. So there is no answer for the ones for the 1C2, there is no answer. So remember that this one, when you do the combination problem, is always the value here must be greater than here. Okay? 2C1, not 1C2. Okay? 8C4, not 4C8. Okay? Because there is no value for the 4C8. Okay? We select this one. We select only 1 from 2. We select 4 from 8. Okay? That's the meaning of the combination. Okay? Alright, so you get the final answer is a 5/9. Okay, 5/9 still within 0 and 1. So the number or the value of probability must be between 0 and 1. It cannot be more than that. Okay? Alright, so for this one, you need to identify the population. Okay, normally you will get to answer this one because you know that the population is based on the two condition. Okay, alright, so the last one is a Poisson distribution. Okay, so for the Poisson distribution, okay, the formula is, okay, the probability of its occurrence in an interval of time, volume, area, etc. for a variable where the lambda, okay, the lambda is the mean number of occurrence per unit. Okay, so for this one, it is always involved with the mean. Okay, and then the mean is a, the notation for the mean is a lambda. Okay, lambda. Alright, so probability of x, okay, lambda is equal to exponential to the power of negative lambda, lambda to the power of x divided by x factorial. Okay, so given that x is equal to 0, 1, 2. Okay, so the letter E you can get from your calculator, exponential or Euler method. Okay, so the E is a constant, which is the value is a 2.7183. Okay, alright, so how you recognize that this one is Poisson distribution is based on the mean provided. Okay, and that it comes from the large number of possible outcome. Okay, so for this one, we can use this formula. Okay, this formula, probability of x is equal to okay. So this one is a constant value. So what is lambda? Lambda is equal to mean. Okay, lambda is equal to mean, right? Okay. We see the example. Okay. Alright, so in a cafe, okay, the customer arrived at a mean rate of 2 per minute. Okay, the mean they are given, okay, customer arrived at a mean rate is equal to 2 per minute. Okay, find the probability of arrival of 5 customer in 1 minute, okay, using the Poisson distribution formula. Poisson. Okay, Poisson, the parameter is a mean. Okay, and the mean is notation by lambda. Alright, so using the Poisson distribution formula, okay, alright, so probability of x, okay, probability of x is equal to 5, whereby this one E negative 2, okay, to the power of 5 divided by 5 factorial. Okay, right, so from this formula will be the mean customer, the mean rate, is equal to, since this one is the word mean, the keywords is a lambda. Lambda is equal to 2, okay, per minute. Right, so find the probability of arrival of 5, okay? Find the probability of arrival of 5. Okay? Probability of arrival of 5 customer in 1 minute using the Poisson, okay? So probability of x is equal to 5. Since you have the parameter already, okay, it's good to proceed with the formula. So there will be E negative lambda, lambda x, k x factorial. Okay, so what is E? That one is a constant value. Negative lambda is a negative 2. Okay, negative is in the general formula, so you need to make sure that negative is there. Okay, alright, so lambda is equal to 2 for x is equal to 5. Okay, and then divided by 5 factorial. Okay, 5 factorial. Okay, what is 5 factorial? 5 times multiply with the 4 multiply 3 multiply 2 multiply by 0. 0 no, stop at 1. Any numbers when you multiply with 0 you get 0. Okay, alright, so you will get the answer. Okay, alright, so okay, if the question, okay, they change to the not exactly 5 but then at most 1, at most 1, we change 5 to be a at most 1. At most 1. How to do this? At most 1, which means that probability of x more than 1. So there will be maybe no customer at all. Probability of x is equal to 0 plus probability of x is equal to 1. Okay? At most, wait, at least 1. This one is at least 1. Right, this one is at least 1. You check again. This one is at least or at most? Probability of, what is this? At least 1, right? So at most will be here, right? Okay. At most 1. So it will be involved probability of 0 and then probability of 1. Okay? Probability of 0, there is no customer arrive at the cafe, and probability of 1 is equal to 1 customer arrive at the cafe. So there will be, what is this? E negative 2 lambda 0 0 factorial. Okay? Alright, so 0 factorial is equal to not 0. 0 factorial is equal to 1. Okay? Correct or not? 0 factorial is equal to 1. Check using your calculator. Don't simply, when you involve this special character here, please use your calculator. Don't simply 0. Don't simply say that this one is a 0. 0 factorial plus E negative 2 lambda 1 1 factorial. Okay. So what is a 0 factorial, class? 1, right? Okay. So, Pavitra, what is a 0 factorial? 1, okay. So 0 factorial don't simply take as a 0. 0 factorial is always 1. Okay. Right. So 0 factorial 2 to the power of 0, 1000 to the power of 0, always check with the calculator. Okay, it is always 1. Not to simply put the 0 there. Okay? Right, so we have example 3. Okay, we skip to the example 3. Okay, so if 3% of the customer arrive, sorry. Okay, so if 3% of the electronic units manufactured by a company are defective, okay, 3% are defective, find the probability that in the sample of 200, okay, less than 2 bugs are defective, okay. So this one you have n is equal to 200 and the probability of defective unit is equal to 3 over 100. So the probability of defective item is equal to 0.03 and then n is equal to 200, okay. So how to find the mean? The mean you can relate with the binomial, which is a binomial, the mean is equal to number of trial multiplied by probability of success, okay. So n multiplied by p, you will get 200 multiplied by 0.03, you get 6, okay. Alright, so lambda is equal to 6 and then for this one, okay, you can directly use the formula because the formula is less than 2. Less than 2 which means that 3, 4, 5, okay. Or maybe you can use the other ways, which is probability of x is equal to 0 and then probability of x is equal to 1. Okay, because the total probability is always 1. Okay, so that the one you can minus. Okay, right, so okay, a special announcement on the midterm, I mean the lab assessment. Okay, we have the case study and then we have a lab assessment, which is lab assessment is 30%. Okay, and then case study also 30%. Okay, so for the lab assessment, okay, we will do on week 9 until week 11 like that. Okay, so far we don't have any midterm. Okay, no face-to-face midterm. Okay, we just do the what we call the lab assessment. Okay, alright. So that one will be conducted in week 9. I will give you enough time to complete the lab assessment. Okay, and that one will be used R. Okay, because that one is assessment on R. Okay, alright. So that's all class for today. Why so many students after this? So they just arrive or another student?
I think another class.
Yes.
So can I ask two questions? So the first one is the lab assessment you said, right? Do we have to do it on the spot during the class?
No, I planning no. I will give you maybe one.
Also, we complete and then we upload like a sign.
Yes, like the case study. I will give you enough time for that. Okay? No worries.
Sorry, so one more question. So for tomorrow's tutorial, is it this one that we're doing?
No, the video will be uploaded.
Okay, later. Thank you, sir.
All right.
It's not in practical class?
Huh?
It's not in practical class?
No, because still on, but then I will give enough time.
Week 9 you said. What is the difference between case study and assessment? Case study is the group assignment, right?
Case study is 30%, lab assessment also 30%. But case study is you are doing the report, but then this lab assessment.
It's the group assignment. By case study you mean the group assignment, right? Okay.
Case study is the assignment of 6.
Yeah.
The one we released before.
Yeah.
The one is not released yet. Okay, so I don't think that is not yet. Okay, just let me know that it started on 6.
Thank you, sir.
No. No, you have to. Yes. I think the way is not that complicated. The way you understand the then it's done.
So when is midterms?
Sorry?
Midterms.
No, I think the lab assessment will be started on week 9.
Is that our version?
You think that the what we call? The midterm will be on face-to-face lecture and so on. No, because
No.
we have a lab assessment.
Oh,
Not
is it
doing in the lecture.
Is it the one where it's like the online one with the?
oh la, teacher, I want cheat, ma. I'm just kidding.
Sorry, Will it have the
Okay.
empty cheat software? Is it that kind of test where it's like you have to download the empty cheat software off my times?
I
Yeah,
don't
that's
know.
like
Are we
for
gonna upload
there
the
was it
code
for
inside
DSP.
time, or are we gonna like download something and then upload it?
Oh, no.
How are we gonna
If
upload
it's
the
there, I
answers?
will let you know what is before. Okay, no worries on that.
So it's online lah, basically. Okay.
Also the date of the
Maybe I give you 3 or 4 days to complete.
Okay.
Oh, okay.
Or you want on the spot class.
Stressful lah, teacher.
Okay, why?
I was asking on the date that time of the assessment. Yeah, for the assessment.
Yeah, online. No exact date yet. Okay, because I went for a preliminary.
Oh, there's no date.
One is like that.
Oh,
Oh, it's a period. Oh.
Like 4 days.
Okay.
Will the site be uploaded?